Hello and welcome to week 2 of SeptembRSE. Thank you for all turning up. I hope, last week was fantastic. I know we've got tons of great things coming up this week and I'm really looking forward to everything we're going to be doing. So without any more pause, we have about 320 plus tickets that we've sent out. So just as a reminder, please be professional. We do have a code of conduct for all of the events that we run through SeptembRSE. So if you've not had a chance to see this yet, maybe this is your first week in the conference because last week you're on holiday, then please do make sure that you refresh, you look through the code of conduct and treat everyone, professionally and with respect. And it applies on everything in SeptembRSE, all of the platforms, all of the communication and everything surrounding it. So again, if you haven't seen any of this welcome talk before, this is like a slightly modified one from last week, then if you want to get in contact with us, then to get in contact with us, we can be contacted via email. So that's the conference email address up there. And then we have the conference information system, which hopefully everyone has seen. It's when you log on to your ticket page and you have lots of things like information about the venue, the timetable, what's going on today, etc. And there is a contact page on there. And at the contact page, you see also various other options you can use to contact us. We also have contact available in the SeptembRSE booth, which is in the Virtual Conference Center. So hopefully you've seen that. Here you can post anonymous messages if you want to get in contact with us anonymously. And there's also a link to a feedback form. So again, if maybe this is your last week of SeptembRSE, please do fill in that feedback before you finish your time with us, just so we can learn about what's been going on with the conference, and it will inform our decision making going forward for next year and future years. So please do that. Running throughout the conference, we have many competitions. The big one, which I'm promoting a lot, is obviously the Oracle Cryptico treasure hunt. This runs throughout the conference, and it's where we have lots of hidden coins placed around the conference venue. There are 5 coins per week. We release them in batches of 5 at a random time on a Monday. And because it's the first person to collect all 20 coins, this means if you haven't, participated yet, you still have a chance to do so. So, you get the first 5 coins and then get the next 5 coins and you'll be just up to date and, caught up with everybody else running. So I put the coins out about 9 o'clock this morning and I saw tons of people obviously watching and waiting, and basically the people diving on the coins already. And these are level 2 coins. So last week, the level 1 coins were slightly easier. I hope you're finding these level 2 coins a bit more of a challenge. And trust me, level 3, you will be cursing me. We are keeping a leaderboard of who is finding the treasure the quickest, and we'll be updating that throughout the week and letting you know about it. And of course, doing the roundup at the end of the week. And there is a real prize for the winner. Anyone can take part as an individual or as a team. And, I do suggest possibly teams because they will have an advantage as we go through the competition, maybe competition between the RSE groups in the country. And again, there's more information at the Oracle Cryptico treasure hunt booth or on the Conference Information Center, Conference Information System. We have loads of conference merch. So I've been seeing the photos that people have been sharing of them having their t-shirts and their stickers and their bags. I've heard it's very good quality. The Society does get some of the money when you buy them. There's the merch booth in the actual Virtual Conference Center. And there's also the links from the website as well. Well worth doing. So the week ahead, we have an extremely full timetable for SeptembRSE. So, we have 4 full weeks of talks, presentations, workshops, etc. If this is your first week, so maybe on holiday last week, then we record everything and everything is on YouTube. So if you go and have a look at the Society's YouTube channel, there is a SeptembRSE playlist and you'll find all of the videos from last week there. So you're able to catch things up. And also there's more information. If you look at last week's introduction to the week, I go into more detail about how everything is working. Now, as I said, for each of these weekly introductions, I'm going to give you a summary of what's going ahead. So again, you can find out what's happening by basically taking a look at the today page for what's happening today on the conference information system. And also by looking at the timetable, just like use the drop down to say what's happening in week 2. And there's a calendar if you're in the GatherTown Virtual Conference Center. If you take a look at the calendar on the left of the screen, you will find the timetable of what's happening there. But in terms of what's coming up this week, we have a very full program and it's very interesting. So coming straight after this talk is the discussion. I'm calling it Python or something else. It's a really nice title. And I think this is going to be a very contentious discussion. I'm very much looking forward to hearing about it. So effectively, is Python the best? Or, maybe what other things should you be learning or, could be using? This afternoon, we have our third presentation session with 3 wonderful presentations and talks looking at a variety of imaging systems. Tuesday is a workshops day. We have 2 workshops, one in the morning, sharing data stories, and one in the afternoon, the open source software showcasing the best. And then on Wednesday, we have our 4th presentation session, and that'll be followed by a blended session with the University of Sheffield. That's going to be interesting how we're going to do that with blended. So effectively, our presentation session will then merge into a blended session run by Sheffield. More information is available on the conference information system, and they also have a sign-up sheet as well. So again, if you aren't part of the conference, but you do want to join the Sheffield session, you can do so, and that way you can sort of see both. On Thursday, we're having a day off. There are nothing scheduled, and that's a chance for everyone to recharge their batteries to then power us through the last 2 weeks of the conference. And then on Friday, we have the Coding Confessions panel, which I think will be very interesting, particularly given the talks and the events last week, and our second post-Lightning talk session. So other things to note. Well, talking of the posters, poster 1005 is now up. So there's a new poster in the virtual conference center. Please do take a look at it. And I talked to the person presenting it on Friday. The workshops that are happening tomorrow, so the Turing data stories, try your hand at writing your own data story, and open source research software defining and showcasing the good. Those workshops, there are plenty of spare spaces on those, but you do need to sign up. So please do sign up to those workshops if you want to come tomorrow. If you're really late on signing up, then do check out the Today page on the conference information system, and you will see the links to those workshops there. As a reminder, our workshops use a different Zoom link to this link. So it's like a link you can only get from the conference information system on the Today page, for example. One of our other workshops happening on the 28th, that is basically the open data workshop run by Amazon. And they're actually running this as a mixture of in-person and online workshops. And so it's going to be in person in Bristol, Cambridge, London, Manchester, Oxford, Sheffield. I just moved this out of the way so I can see a little bit. Yeah, Oxford and Sheffield. And they'll be able to support some remote teams. There's going to be competition between these sites. They have capacity for 2 teams at each site with up to 4 remotely and at their offices in London. Please put together your teams of 5 and then make sure everyone registers. And there's a registration page for this, which is on the SeptembRSE channel in the RSE Slack. And I'll make sure to add this to the workshop information page for this particular workshop. That's going to be a really big thing, and it's right at the end of the conference. You have lots of time to put together your teams and to register for this. And then another point to note, a jukebox has been added to the dance floor to show off all of the wonderful new music that we have this week to share with you. So that brings me to the end of this welcome. As I said, the last week as well, please do engage with SeptembRSE. I was so pleased and happy to see everything that was going on last week and how people were really treating it like a conference, and all of the networking and all of the sort of the fun events and that sort of buzz that you get when we all come together. And as I said, there's about 300 plus of us. So, please do engage with the conference and engage with the virtual conference center, and you will feel that this is a conference, trust me. So, don't just make this like the best RSE conference, make it the very best RSE conference you've attended, and make SeptembRSE more than the sum of its sessions. So with that, I'm going to stop sharing this screen because we're going to have a discussion session next. So before we have the discussion session, we're just going to have a 5-minute break just to enable the discussion participants to get together. Just let me prepare that. Share screen, and I have to mute here, otherwise you'll echo all of the music. So I'm going to stop now. I'm going to do a 5-minute break, and when we come back, we have a discussion on Python, which I think will be very, very interesting. I'll see you there.
Good morning, everyone, and welcome to today's discussion session. The title of this session is, it's a long one, so bear with me. Python is ubiquitous in research, even when it is not the optimal solution. When is it worth investing time in a more specialized, but harder to learn / maintain programming language? Or as Christopher called it, Python versus everyone else. The discussion session. So welcome, everyone. I'll start by introducing myself, and then I'll ask the other panelists today to introduce themselves, and then we'll jump into the discussion. We're aiming to end at about 10 to 12 today, so we've got about 45 minutes of talking to do, so hopefully we'll keep it entertaining for you all. So my name is Matt Williams. I'm a research software engineer at the University of Bristol. I've been doing this, well, I started as a research software engineer, but basically at the same time as the first RSE conference back in 2016. So I started just at the beginning of the big movement when it all started. Most of my day job is spent teaching people Python, data analysis, Git, things like that. And as with most of the people on the panel today, most of the programming that I do is in Python. But as we're going to work through today, there's various other options and ideas out there that we're going to get into. So I think that's enough for me. I'll go round the room now and ask people to introduce themselves, starting with, let's see who's first. Terry, would you like to start?
Yeah, I can do. Thanks, Matt. So I started as a research software engineer unofficially when I was doing sort of PhD and postdoc. I was the bioinformatician in a developmental biology lab, and I sort of became the RSE, even though I hadn't heard the concept at the time, for sort of our lab and a few other groups nearby. I taught myself Python when it became clear that Perl was no longer considered a cool language and everybody was sort of moving over. I then became an official RSE at the University of Leicester, where I was the Python specialist, which is an exciting title to have when you are self-taught. And I'm dealing with massive imposter syndrome. And then I am now a full stack software engineer at the Wellcome Trust, also a freelance RSE, and I still primarily work in Python, but have now sort of expanded and moved on to other things when the time has come for it.
Thank you, Terry. Let's move on now to Thibaut. I see you're next on my screen.
Hi, thanks, Matt. So my name is Thibaut Lesson. I'm a research software engineer and at the University of Oxford. I come from a background in computational physics. I think I first really kind of did some kind of research software engineering work as a PhD student. It was computational fluid dynamics, so a lot of programming in mostly lower level languages. So it was C++ at the time. I was not really touching any Python. Most of the scripting was actually done in MATLAB because that was the stuff that people used next to me. But most of my day job was programming in C++. I then moved to work as a performance engineer in the high performance center in Stuttgart. And so there was a lot of, again, C, Fortran, to try and optimize performance of software. And I actually really started using Python when I arrived in Oxford about 2.5 years ago. And then the kind of stuff that I was actually focusing on was more software engineering, more than actually HPC, let's say, to kind of split that. And so I did a lot more Python. And yeah, taught myself Python. And then nowadays, I basically work with researchers across the University of Oxford, and most of the projects are Python. But some of them actually mix both C++ and Python at the same time.
Wonderful, thank you, Thibaut. Moving on now to Jamie.
Hi, all. Yeah, so I'm an RSE at UCL in London, and my Python journey. Python was the second language I ever learned, actually, after C++, which was a bit of a mad language to start with. But I think that's kind of influenced where I've ended up, because I've used C++ a lot in different kind of HPC contexts. And I like that I've managed to, just through all the various things that I've done and jobs that I've had, I've touched an awful lot of languages. Kind of, I would say at surface level, you know, doing bits and bobs. But I always come back to Python. It's one of those languages. I recently heard a quote that it's the second best language for everything, and I think I totally agree with that. But I'm interested in the HPC side of things, and how Python can be used. We use it as a core language for HPC, and I think it's getting there. It's almost there. You can see it in the kind of HPC side of machine learning, but less so in kind of more traditional scientific HPC. So, yeah.
Great, thank you very much. And last but certainly not least, Shen, do you want to take over?
Hi, everybody. My name is Chen, and I'm doing my postdoc here in Aberystwyth. Before I work, I did my PhD in Singapore, and I got to apply the Python language for quite a lot. Actually, some of my code written there, I use Python. And also later, I am hooked with Julia, a new language, which is, I think, very promising. And I also use some R and certainly MATLAB, because I work in the engineering sector, civil engineering before, and I have to deal with lots of codes in MATLAB. But now as a researcher here in Aberystwyth, I'm doing in physics, solar physics, and the programming they use IDL and Python. Yeah, so I hope that some of my experience can contribute to the topic today. Great to see you.
Great, thank you very much. So I'm going to try and keep the conversation a bit freeform today. Don't feel like you need to put your hand up in Zoom to say something. Feel free to just jump in with ideas and thoughts and so on. But if you do feel like you're struggling to get a word in and you want to stick your hand up in Zoom, then I'll make sure I call on you and try and keep track of everyone to make sure everyone has a chance to have their say and contribute to make sure it's all fair. But let's start off. I did prepare a few little questions to kick things off. I think a good place to start perhaps is focusing on Python as a language and have a little discussion about where we think Python does fit particularly well. Why is it that Python has caught on so well as the language that 80% of researchers know and are working in and so on? Has anyone got any thoughts on why they think that Python is such a popular and pervasive language at the moment?
I'd say that I think it's an easy one to teach and to learn when you're new to programming. So I think it provides a sort of a nice route into doing any kind of programming. I mean, when I was teaching things, I remember when I was first doing my postdoc, actually no, PhD, sorry, further back than then, the only programming course that was available at the University of Nottingham at the time, bear in mind this was many, many years ago, was Java. And that was a really hard entry point with a sort of like, for the first 5 lessons, you're typing out a lot of things that you just don't, they're not even going to tell you what that is. You just have to copy and paste that every single time. And then to be able to then go off when I was an RSE and be able to teach Python, it was such a smoother process. So I think that has a big impact.
Yeah, I would agree with that, actually. It's the fact that you can start off with a script. You know, thinking about, you know, I've recently done the carpentries instructing training, and you know, the idea of making sure that there's just one thing that you're going to teach next, you know, and so, like, you know, you start with something like C++ or Java, you have to introduce functions right at the beginning, because, you know, everything is in functions, but Python, you have to do that. So I think there's just a nice kind of ramp into more complex things like classes, or, you know, functional programming or functions.
And I think, and onto that, it also builds on the fact that Python is incredibly easy to read. And you can basically, if you write that script, Jamie, and then you pass it to somebody who's been programming in R, they can probably read it. They can probably understand what it does. You know, if you not everything, but usually, you know, the language is usually very easier than most programming languages to read, I'd say. And that's incredibly helpful. That's also make it really easy to teach. I mean, easier than, it's not easy, but it's easier than if you were to teach C++ or Java, I guess. I think, in my opinion, the second advantage that perhaps is a little bit more technical is how Python can interface with C. I think it's made really clear how it does that, and it's been kind of built with that feature in mind, and this is thanks to that we have NumPy, for instance, and that's the reason that actually Python is now used in more data sciencey areas. It's because we have NumPy, we have SciPy, Pandas, and all of that builds on the fact that people were able to take fairly low-level performant trusted Fortran C libraries and then make Python bindings for them. And that was, I think that really helped Python to kind of expand to other areas than where was it originally used.
Yeah, I completely agree. It can be divided into two phases. First, before 2010, I found that Python is very easy to learn. So we can self-teach and experiment with the interpreter, and I think it's a great feature. And then after 2010, you know that lots of media attention on the language, and people started learning about it, and then just like a snowball, every people knows, and it will be very popular and everyone can communicate with using this language.
Okay, good. Yeah, so it sounds like everyone has a similar kind of thought that it's the ease of getting started, and those things that it makes simple really lets you get hooked in. It's that, you know, it's like addictive in that sense. You start and then you find that extra feature, extra ability, and it just keeps on providing the next thing that you need to be able to solve your problems. I guess I'm wondering.
Actually,
so yeah, go ahead, Jamie. Go ahead.
Sorry, it was just to jump on that point. Actually, that I think Jupyter notebooks are a big part of that. That, you know, having fun, like getting immediate feedback. It's almost like a game. You know, it does end up being addictive.
Yeah. So I guess I'm wondering, and I think that's a good example of what I'm thinking about for the next point is, where does it get used that's maybe not entirely appropriate, or where does it get spread too far, used in corners of the world where maybe there's other things that would be better, or maybe it's getting used in ways which are encouraging potentially bad practices? Have people come across situations like that?
Yeah, I think you can definitely find because as you know, as Jamie pointed out, it's very easy to start with a script, and it's fairly easy to get some place where you got a script that does what you want it to do, and then you can just send that script into your local supercomputer and make it run for days, and then you get an answer. And it's fine, because as a PhD or postdoc, you know, you've got millions of other things to do. So if it takes, you know, it could take one day, but if it takes 4 days, then you just, you know, work on writing your next paper or whatever. So it doesn't matter. But then the problem is, one problem with that is that you know, you're using quite of energetically expensive resources, and you don't really see the impact of that. But if everybody does that, then we have a problem. And then there are now, I think there are a few papers. There's at least one paper I can think of. I can put a link in the chat that talks about this, about the fact that maybe, you know, just throwing your Python script to your workstation, or perhaps a bit better to your local computing center, is not necessarily a good thing to do. Not on the scientific point, but more in terms of like thinking about the impacts of your research. That's the one thing I can think of in terms of the kind of practice that Python would encourage, which is also one of the big advantage of Python, but also it kind of like it allows you to do that, to just like send your script and then make it work without thinking about it.
And do we think that that's a problem with the language, a problem with the teaching of the language, a problem with how the resources are advertised and structured and so on?
Yeah, I guess you could do that with C++ as well, right? But it would be a bit, it would require a bit more work, I guess. With Python, did this kind of, you just have something that works really quickly, and then is incredibly portable. So you can just make it work a bit everywhere. I don't think it's just Python. I think you're right to point that out. But I do think that this way of working is made even more possible with this sort of languages. And it's not a bad thing. I'm not saying it's a bad thing. It's just it's one of the reasons Python is so popular. But then there must be, and we can't ask that any scientist like really is an expert in optimizing, and that's why we have RSEs, I think. But that's another topic.
Yeah, talking with R, it's a case of difference in Python, because with R there are many books to teach for introduction. I remember the days in 2006 or so there, I had to self-taught Python and write a bunch of maybe very inefficient code just to experiment with it. And later, more and more books are written for this language, and then there are clean code Python books, and then I think the practice get improved a bit. Anyway, it's just for a problem for the language, which is too popular at the time.
Yeah, I'm not sure I could think of an example where I could say Python was the wrong language to use in that particular circumstances. I've definitely seen cases where Python was used poorly and wasn't written in the way it probably should have been for that particular problem. But that's slightly different. And cases where I've known that we have moved away from Python for a particular process or service, you're trying to add something else to it. You're trying to have a sort of a slightly different increase in speed or slightly more parallelism. But Python would still have worked, and it would have still been perhaps not the best decision, but it would have been perfectly adequate, and it would have potentially negated other side effects of moving to a slightly more obscure language.
Yeah, so I mean, there's often this trade-off that gets talked about with fast and slow languages, that languages which are slow to run computations are fast to write in. You get your job done quicker. You express your ideas onto paper more effectively. Whereas other languages which may be really close to the hardware are really cognitively difficult to write in. And then there's always this trade-off. And historically, I've heard it said that a programmer's time is more expensive than your customer's time, sort of thing. And so you're best off spending the time to write the code well, and then it's going to, and so write the code in an efficient way, so that you take less time to write the code, and it doesn't matter if it runs a bit more slowly. Maybe that trade-off is a little bit different in research. I mean, I've heard that expressed in terms of industry, and only offhand, not in any kind of formal way. But at the end of the day, we need the research to be done. We need the answer. We need someone to actually get around to doing it. And someone who's a domain expert in a particular research field can't necessarily be expected to be an expert programmer at all the languages. So maybe it's, regardless of whether it's the best language for something, it's just important that there is a language that they can write effectively in and can express their ideas in. And that's the first thing that you have to tick off. And then you start worrying about performance and optimization and all those things. Quality first and ideas, then those other things.
I think there's an element of Python though, where I think because Python doesn't go in for any one kind of programming model, object oriented is kind of tacked on, functional stuff is kind of tacked on. It doesn't lead you down any one path, and I think that can sometimes be, particularly for folk who are not software engineers, that's difficult to manage complexity at scale. You're then writing a code, that's 10,000 lines long, 100,000 lines long. In Python, that's going to be tricky compared to, I think, languages like C++, Java, even Fortran that have more structure.
Yeah, and I think it comes back to that ramp that you were mentioning earlier. I think with Python, that ramp can be very, very long. you can stay on that ramp until, like you say, you've got 500,000 lines of code. And because you built it up part by part from something very small without the design overall in mind at the beginning, because it made it easy to do that, you can end up with hard to maintain code. I think any language which fit that niche of this is the easy language for people to learn would suffer that same problem. And I think, again, it comes down to that idea of maybe education and training in those sort of software design principles is useful in any language, but the impact would maybe be greater in Python because there's more people who are just climbing that ramp. And again, RSEs fit a really important role in that whole situation because we can be the experts to provide guidance and help to structure the code and control that complexity, which, as you say, is always one of the trickiest parts of software.
Yeah, I think bringing it back to where's the optimal solution is the researcher's time versus the customer's time or something like that. I think one of the other big things that I think the reason why Python works so well is it's kind of self-explanatory, but it's the number of people who can write in it, and project longevity is normally far longer than any individual person. And it might be all very well for one person to teach themselves a new language, to write some beautiful code that works extremely well at what it does. But if nobody else in the team or an RSE available or anybody else is able to actually also work in that same language, then it can't be continued and maintained and supported beyond that time that researcher is there. And I think that's one of the big issues for me, is the points where we have gone, okay, we're going to write this in Rust, and it works really well for that solution. There's only 2 of us in our team who know Rust, and I've had to learn it as I've been going on. So my Rust is mediocre. So you're kind of in that situation as like, well, now what do we do if we move on? We're going to just leave these services behind, that we're going to ask other people to now have to invest the time in learning a new language just so they can support the code that we've written. And I don't know if that has, if that's worth it.
Yeah, I guess that's getting to the crux of the key question of this is, what is that trade-off? What is that trade-off between something that's hard to learn, but maybe you end up with simpler, more expressive code, but you need to learn a really specific language to be able to write in it, versus something which anyone can pick up, but is maybe not going to be engineered as well because it's going to be built on by lots of people, and is therefore easier to maintain because you can find people to maintain it, but maybe less easy to maintain because it's more complex. That trade-off, I think, is key. So to jump into more specifics, has anyone else got any examples when this has happened, or when you've been worried about this happening with other languages being less popular, less maintained, less usable, and trying to balance that in your groups or your research?
Yeah, I think Julia is a great example of that. UCL, where I've been trying to learn Julia, but it's a different programming model again. So not only is it, I think, maybe harder for a researcher who might look at some of our code written in Julia, but it's harder for us as RSEs to get into a different headspace, and is as many advantages as Julia may have. It's tricky learning this new language and new programming model.
Maybe it's just reside in the mindset, because if we are used to one language, it's very hard to switch to the other. Remember the days when MATLAB was so popular and Python arose. Then I think most of the MATLAB community didn't want to switch to that language until recently. Yeah, that's a problem. And the second one, I think, is still most of the users are from engineering community, and it's hard to persuade that there is a better model of programming. You mean, how can we explain functional programming to the people in engineering, others than software? It's very hard for them to grasp the new idea.
I guess it's a bit of a network effect as well, and in terms of if all of your colleagues are using Python, and you should probably use Python. But how to be the first person, to simplify things, the first person to choose another language? Yeah, I guess it would have to be motivated by really strong both scientific and also software sustainability motivations for one to make the choice to actually, okay, I'm not going to use what everybody uses, I'm going to use something else because this and this, which I can't really define it. I guess it depends on the field. I think in certain communities, it's going to depend. Yeah, it's going to depend on the community. In certain communities, there's already a significant part of people who are familiar with another language, perhaps C or Fortran. My experience in fluid dynamics, that's fairly the case. There's most of the big computationally expensive packages, they're written in this sort of language, so people are usually, at least they know a little bit, they know enough to know what would be a good thing to do in C and what would be a good thing to do in Python generally. It might not be the case in other communities, and that's probably where having an RSE team to deliver this sort of training is I think absolutely crucial.
Yeah, so I think one of the ways that you go about starting to introduce a new language is to identify those small, isolated, encapsulated parts of your process that you can rewrite something in, where you can take that risk, and if it doesn't work out, it's not a problem because you can just rewrite it again in a different language, or it's small enough that it doesn't have a large maintenance burden. So with something like Rust, for example, you might have a Python library and you might implement a small part of your core algorithm in Rust and link it into Python. So Python's doing most of the standard stuff that people are going to be interacting with, the user-facing stuff, but you've got your core algorithm written in Rust and it's sort of paired away somewhere out of the way. So you're able to take that risk, to run that experiment, to see if it fits for your kind of research workflows, to see how easy it's going to be to get people to come along and support it. I think you kind of have that same issue at both the beginning and the end of a language's lifetime. At the beginning, you're thinking maybe we should start using Rust for something. But then at the same time, as Toby was saying, if you're thinking maybe we should write this in Perl, you're going to be having those same issues. You're thinking maybe this is the perfect language to write this text processing bit of code in, but am I going to be able to hire someone to maintain it? And if it is perfect, you'd have that same issue of let's keep it separate, keep it isolated, and run that experiment to see if the cost is really worth it.
Yeah, that's a good idea, actually, to actually experiment with how you write these parts of a particular bit of software or something. And I think it's very easy to get overexcited when the new big language or something comes out, even if it's a new framework or something, even in Python, that people get, oh, I want to have that, give that a go, and before you know it, you've got yourself into a place where nobody else can rescue you from. Yeah, don't throw yourself off a cliff without testing the waters first.
Yeah, I mean, in research, we are generally quite far behind industry. So we do have experience to lean on. We're not generally the leaders when it comes to picking up a new language, for example, because we tend to have more inertia. It feels like smaller startups are more likely to come along and run that experiment for us. And we can see, oh, okay, there's an RSE independent group doing everything in Julia, or there's a company over there doing everything in Rust or whatever. So we should make sure that we keep our eyes open to the outside, I think, watching what people outside of academia are doing, as well as what's inside academia. But yeah, I think that experimentation is key.
It's very difficult though, because as a researcher or RSE, do you have the time and the incentives to actually carry out these experimentations? I don't know.
Yeah, that's the risk. Does anyone here feel like they'd risk trying a new language as part of a project? I mean, Terry's mentioned that your group has done already, but Jamie or Shen, have you run that before?
Actually, risk, I didn't experience that, but it depends on the recipes available in that language. For newcomers, I just want to get some kind of cookbook for that. For example, programming GUI databases, web, all of that. Python can have existing resources for them. But if you want to see Julia, it's harder. Or earlier there was a interesting language called OCaml, which is F# variant. And then it was so advanced, it was so solid, but so not very popular because it's limited functionality, and people have to be driven away from that.
Yeah, so I think there was this network effect of finding things which are going to be working within your domain. If you can find other people who know OCaml, for example, then suddenly maybe that's worth running that experiment, writing the code in that sort of thing. But I think it's easy to forget the network effects that differ from society and group to other group. Like one large group might be using Julia for everything, another one might be using Python for everything. And thinking about how your code is going to be able to be transferred between those groups, I think is easily forgotten because you consider your world to be this area where everyone does it one way. So I had a situation, for example, where I'd found a paper publishing some algorithm to do with some geometry stuff that I was trying to use in one of my research projects, and they detailed the algorithm in text, but they also provided a MATLAB bit of code implementing the algorithm. Now I don't know MATLAB. Perhaps in their environment, MATLAB is completely the common language to implement this kind of thing. But for me, it was a lot of work to try and pick apart what exactly this was doing. The text of the paper wasn't quite detailed enough to know exactly what to do. And I couldn't understand the MATLAB, but between the two of them, I could just about do it. But I knew that whatever I was going to do, I was going to have to rewrite that code in something in order to implement it and incorporate it into the thing that I was doing. And I was trying to choose between, well, Python would be the default, but I was thinking, would this be an opportunity to take this algorithm, write it in something like Rust, and then link it in? And I was having this same sort of problem of, if I do that, then the next person coming along is going to have to need to understand that. And you can smooth it over, I think, by doing the RSE thing well, by good documentation, good testing, good, well-designed APIs, so that it's hopefully not going to have to be touched. And if there are bugs, it's easy to work out where they are because you've got a good extensive test framework. But it was interesting going from that, I'm at the edge of one network over here where they use one language, which I don't know, and then thinking, well, maybe I should just do that same thing again and call someone else that pain. And that kind of gave me a bit of pause. But on the other hand, if you don't try these things, everyone will be using Python in 70 years' time when maybe it's not going to be appropriate anymore.
Which version of Python will it be by that point?
Oh yeah, quite. I mean, maybe I'll be Python. Well, the way they're going at the moment, they'll still be on Python 3. 3.70 or something.
Can I ask a question to the panel? Do you think it's important, and do you think it's a useful part of Python that they have versions? They're not, say, like C++, really stuck to backwards compatibility?
I think it does cause problems. I've seen issues. I mean, particularly with the Python 2 to 3, because there was this larger break there where someone was working against an API of a proprietary piece of software which only provided a Python 2 API. And so we had to make a Docker container with an old version of Ubuntu to have the old version of Python. And it was all this big mess because you had these kind of hard breaks. Now we've got much better backward compatibility. It's not perfect still. They do still remove things from Python. It does still cause this sort of reticence to use the latest versions of things. But I think that with the right level of CI and testing and stuff, you can try to smooth that over if you're in a world where you can do that kind of thing. What about anyone else?
I'd agree with that. I think now I feel that in Python there's a region where I know that I'm not on the bleeding edge. I'm not too far out. There's a clear at the moment. You know 3.8, 3.9. I feel relatively confident. And as you say, provided that you have some testing, then and if something goes wrong, it's not going to be too bad. This is my own feeling. I don't feel particularly, in danger of anything. I know I'm not going to be using any features that people would use, and even if it's the case, then it's not going to be a big change for me as a developer to take that into account.
Yeah, I think the pace change is different though. Having sort of working most of the time not as an RSE with Welcome, like if something new comes out, new version, we'll tend to upgrade fairly quickly, and part of that will be an excitement to use whatever new features have come out, but also let's make sure that everything works with that. But we have all the testing and CI in place because that's just part of what we do. Whereas certainly from when I was an RSE working with researchers, it's much harder to make any kind of change to new versions. I mean, I absolutely think that there should be new versions. I think the change from 2 to 3 in Python was a bit of a disaster, but I think everybody knows that, including the Python core team. And they have said that Python 4 will not have that kind of problem again, and they're never going to cause that to the community. But yeah, it is a slower pace of change and an ability to update and upgrade and even think about that when your primary goal is not the software. It's the answers that bit of software will provide.
Okay, so another thought I was having about sort of on that similar theme of new features that Python's added. So you say that the thing that matters is the answer and the code itself isn't important, which is true at the end of the day. But I think we all know that it's important that the code is correct and is giving the right answer and it's robust and it's not going to have weird bugs and corner cases. And Python historically is in that category of fairly relaxed languages which let you get away with quite a lot, which is often going to give you bugs compared with something like C, C++, Rust, etc., where they're relatively strict. They're not going to let you just pass bytes when you meant to pass a string or something and mess up your encodings. They're going to force you to do it properly, at least a well-designed API will. Python is much more relaxed with that. In recent years, we've seen various additions to the language. I think the main one that I've seen which tackles this kind of thing is the idea of typing in Python, being able to say this thing takes this type of data and you can then run static checkers on it and make sure that, yes, it really does. What features and additions to the language do you think you've seen recently which have really helped give you confidence in using it broadly in a research context? And is there anything that people think is missing that they'd like to see or like to see improved in Python to make you able to say, yep, perfect language for everything, use it, don't worry about it?
A tiny thing is F strings. I love F strings. I can't remember, it's relatively recent in Python, but I don't think cutting edge, but it just makes them so much easier to read. It's lovely. I think that's bizarrely a really powerful part of Python now. It's just like this ability to write really easy to read strings that then output the answer, hopefully.
I would totally agree with that. F strings are brilliant. I was going to ask, does anybody here use typing in Python?
Sometimes.
Not really. But I
No,
think
sorry, go ahead.
sorry, you go.
I was about to say no, and I feel pretty bad about it. I think I should, because it helps with making sure that the less bugs, but also I think it makes just the code easier to read. So I think I should do it, but I'm not doing it at the moment, to be completely honest with you.
Yeah, I think in newer version, Python is kind of improving in new practices. Yeah, I agree with Terry, because the shifting from 2 to 3, and particular the kind of they change from the statement to a function. That's at the beginning I was so embarrassed to see that Python use that as statement, which is unlike other languages with they didn't use any parentheses around the print, and then they correct it. And now with the typing, I think in the end they may be nearer to some modern languages, but yeah, it's just I don't know if they can replace entirely or not, or just kind of patches here and patches there.
Yeah, so I guess that Python's gone through this growth, as you say, Shen, to become more modern, more like a real programming language, adding in these things which give it more consistency, more predictability, make it compete better in that kind of environment. And I do think it's getting much, much better at being able to give you that confidence that your code's going to work, it's going to work everywhere, and everything's going to be great. I guess one of the driving forces behind Julia was to kind of be a better Python. From a certain perspective, it was, let's make this as a consistent modern language. We'll get rid of the warts, the old stuff, the thing that doesn't work anymore, the stuff that clashes, write it from scratch, do it how we want it to be, and that's going to be there. And that was replace Python with Julia and your life's all going to be better. And I think with Rust, there was a similar thing of, particularly from the places that I would use it, I see it as competing most directly with C, C++, Fortran, that area, particularly C++ in my experience, but I guess C as well, that it's the low-level language which you'd write your fast algorithms in, and then you wrap it in Python on top, and it's all going to work quite well there. So I guess there's some languages that I see as competing directly with Python, and others which are competing with other languages and are going to supplement Python. So it's never just a direct competition, I guess is what I'm saying. I think they're all learning from each other and all improving, which is always quite interesting to see. Python's famously learned from other languages. It was inspired by Rust, for example, with its recent match statement stuff that's brought in, inspired by C# for its precursor to F strings, all this kind of thing. So they are bringing each other along quite well. Let's see, has anyone else got anything to add while I check my questions? And then we should wrap up in a few minutes anyway.
Yeah, I was just thinking about how it'd be so nice if Python had a const, a way to specify const. That would be my one thing that I would add to Python.
Yeah, no, I agree. I think it comes down to that rigor. One of the things I like about Rust, for example, is that things are const by default. And going back to Python, I find I really miss it. That idea that it makes you feel like everything's on a loose foundation. You have these kind of emotional responses, I find, when I'm programming. You find things that you like and things you don't like, and things you miss, which is weird because it's just syntax. And I agree. I think things being able to say this is a constant, and you can get static checkers which help with this kind of thing, but Python, you can always just crank up the hood and do whatever you want underneath and get around things, which is its power, and it's also perhaps its weakness.
It's not just about correctness, you know. I remember writing some C++ code and I was like, oh, I'm going to use const actually for once, because before that I was just like, constant. And I didn't. The code was like twice as fast, just because the compiler was then able to, you know, work out some really interesting things, and it worked out. So I actually, you know, even having it for a performance reason would be nice.
I think there's something that we didn't really touch about as linked to that is, you know, this idea of writing the kind of the outer shell in Python and in the core in C, or doing a little bit of C. It asks, you know, you have to know a little bit about C++ to do that, and a bit more about Python. But there are a whole class of tools that you can use. I'm thinking about Python, thinking about Python, Number. All of that is some sort of tools that you can use to actually make your Python go, you know, being much more efficient. And then usually you don't need, it doesn't require a lot of work for you to make that happen. I think if you want to really tweak it the way you want it, then it's gonna ask you a bit of effort, but it's usually quite easy to use. And I know for instance that, you know, Number is there's a lot of development with that project, and there's a lot going on. So I think it's worth, you know, checking it out. The idea is this idea of actually taking Python code and having some sort of compilers for Python, at least for a subset of the language. I think it's a very powerful idea.
Yeah, definitely. So we should start wrapping up now, but we do have a bit more time if we want to add any closing statements. I think my sort of closing thought, which has only just occurred to me, I didn't prepare this, is that learning other languages is beneficial, even if after learning them, you're going to go back to Python. I found after learning something like Rust or JavaScript or whatever, going back to Python, I write things differently. I learn about functional programming. I learn about consts. I learn about structuring code with different kinds of inheritance. It improves all my code by learning something new. And I think that even in itself is a valuable thing to do. Anyone else have anything they'd like to wrap up with?
Yeah, I'd actually like to add to that learning Python actually and using kind of being able to play with object orientation in a much more experimental way, a much faster way, has made my C++ much better, because I feel like I understand object orientation much better just having experimented in Python.
Yeah, the only thing I'd like to add, which we haven't said, is actually about the communities that go with these languages. Now, my experience of other languages is quite poor, but even though I now spend 90 to 80% of my day working in JavaScript, I want to carry on with Python just so I can keep attending PyCons, because they're such a lovely community and it's such a great bunch of people.
Okay. If no one has anything else to add, I think we're just about on time there, so we'll wrap up there. I think there's been lots of discussion going on the Slack, so anyone who's still in the session here listening, if you want to carry on the discussion, head over to the SeptembRSE channel on Slack or head into GatherTown and carry on talking about this stuff. I'm sure there's lots of opinions flying around. I'll try and catch up on those and answer after I've had some lunch. But I'd just like to thank all of the people on the panel, Terry, Thibaut, Jamie and Ken, for the session today. Thank you for your time. Thank you for the interesting discussion. And thank you everyone for attending and listening. I hope it was useful and hope you enjoy the rest of SeptembRSE. Thank you all very much. Bye-bye.
Thank you, Matt.
Goodbye.
Cheers all. Bye.